Yeah. Note on the next problem. Note on the next problem. This was asked in January 18 also for 8 marks. A cantilever beam with a span of 800 mm has a rectangular cross section of 200 mm depth. Please note down the problem. Look at your screens and note down the problem, or follow my words and then note down. A cantilever beam with a span of 800 mm has a rectangular cross section of 200 mm depth. Okay. The free end of the beam is subjected to a transverse load of 1 kilonewton that drops onto it from a height of 40 mm. Selecting C40 steel, he has given you sigma y to be equal to 328.6. Okay, so you don't use 324. He has given you 328.6 in the paper itself. So use the same value. And FOS is equal to 3. Determine the width of rectangular cross section. Please note down the problem first. Please note down the problem. Noted down? Yeah,
1 minute, sir.
Done?
1 minute, sir.
Yeah. Note on the problem that is seen on your screens. Okay, I think you have finished noting down the problem. Okay, we'll look at the solution now. Yeah. Yeah, one of you please read the problem. Bansali, can you read the problem?
Yes, sir.
Please read it.
A cantilever beam with a span of 800 mm has a rectangular cross-section of 200 mm depth.
Yeah.
The free end of the beam is subjected to a transverse load of 1 kilonewton that drops onto it from a height of 40 mm.
Okay.
Selecting C40 steel with sigma y is equal to 328.6 megapascals and FOS is equal to 3. Determine the width of a rectangular cross-section.
Okay, yeah. So please look here now. This is a cantilever beam, okay, with a rectangular cross section, and the depth he has given you to be equal to 200 mm, correct? So he has given you depth of cross section to be equal to 200 mm, and we need to find width of the cross section, and he has given you the span of the beam, okay, that is the length of the beam. L is equal to length of the beam L is equal to 800 mm. That is the span of the beam he has given you, okay, in the problem. Okay, this is 800 mm is the L value, and free end of the beam is subjected to a transverse load of 1 kilonewton. That is transverse load of 1 kilonewton or 1000 Newton, 1 kilonewton, which is dropped from a height of 40 mm, correct? So this is 40 mm height through which this 1 kilonewton is being dropped onto free end of the cantilever beam. And we are given with material yield stress as 328.6 and factor of safety to be used is 3. We need to determine the width of the rectangular cross section. So note down the data there. So D is equal to, that is depth of cross section is equal to 200 mm. Okay, depth of cross section is 200 mm. Length of the beam L is equal to 800 mm given in the problem, and the value of W he has given you in the problem to be equal to 1 kilonewton, that is 1000 Newton. Okay, that is 1000 Newton. And what else is given? Height of fall. Okay, H is equal to 40 mm given in the problem. Okay, that is what is given, and then we are given with sigma y to be equal to 328.6 megapascal, and factor of safety is how much? What is the factor of safety? Is equal to 3. Factor of safety is equal to 3. So therefore our sigma I will be equal to 328.6 divided by 3. What is the value of 328.6 divided by 3 is equal to? Can someone give me this value?
109.53.
109.56, no?
53.
Okay, whatever. So this is the value of sigma I, that is 109.5 megapascal. Okay, so we have the equation for impact stress given by sigma I is equal to sigma 1 plus root 1 plus 2h by delta. Okay, this is the equation for impact strength. So find out delta, which is for a cantilever beam loaded at its free end, is given by WL cube by 3EI. So here I is equal to BD cube by 12. Okay, I is equal to BD cube by 12 because it's a rectangular cross section. So now you are going to get the W is known, L is known, Young's modulus you can take it as 207 GPE, and I is BD cube by 12. So therefore you get delta is equal to something divided by B, correct? Because D value is known. And then bending stress is equal to bending moment divided by section modulus. Bending moment is what? 1000 into 800 is the bending moment, and the value of Z is equal to how much? It is BH, that is BD square by 6. BD square by 6 is the value of section modulus. D is known, B is not known, so you'll get sigma also in terms of B. On the left hand side of impact stress equation, you know the value of sigma I, that is 109.5. So sigma is in terms of B, then you have delta in terms of B, H value is known, so only unknown is B, so get the value of B. Got the clarity now? Did you get the clarity? Please solve the problem and get me the value of B. Anybody, any doubt in this? It's a cantilever beam loaded at its free end by a transverse load, so you are going to have bending stress sigma. Height of fall is the H value that is given by 40 mm out there. Okay, and depth of cross section is 200 mm given in the problem. Length of the beam is 800 mm given in the problem. Sigma y of the material of the member is 328.6 and FOS is equal to 3, again given in the problem. So therefore, with sigma y and FOS, we find the design stress or sigma I to be equal to sigma y by factor of safety. Okay. So that will give us 109.5 megapascal as sigma I. Right. So find out delta in terms of B, find out sigma in terms of B, substitute in the impact stress equation, you will get the value of B. Anybody? Any doubt in this? Any doubt? Please give me the value of B.
$79.82.
79.82. Others? Others, what is the value of B? 79.6 or 80 mm, correct? Correct, Tarun? That's the answer.
Yes,
So it is
yes, sir.
80 mm is the answer for B. Others, have you done the problem? Those who could not get the answer, please note down from the screen. Yeah, so this is how you are going to get. Delta from table 1.4 is given by WL cube by 3EI. Young's modulus is 207 into 10 power 3 megapascal. And I is pH BD cube by 12. So B is not known. So you will get delta is equal to 1.24 by B. And then find out bending stress, which is equal to bending moment is what? Force into perpendicular distance. This is 1 kilonewton out there into distance is 800 mm. So 1000 into 800 will give you bending moment. And Z is BH square by 6 or BD square by 6. So therefore you will get sigma is equal to 120 divided by B. Substitute in the equation of impact stress. So we know sigma I is 109.5. How you are going to get this? Your sigma y is given, FOS is given. So therefore your design stress is going to be yield stress divided by factor of safety will give you 109.5. That will be the impact stress, which is limitation. So for the limitation of 109.5 megapascal, this is the value of B that you should make. That is, the cantilever beam should have a cross section of 80 mm by 200 mm. For it to not to cross 109.5 megapascal, when a 1000 Newton load is dropped from a height of 40 mm. That is the understanding. Okay. Others, please copy from the screen if you are not done. Is the values on screen visible, Tarun? Is it clear there on the screens?
Yes, sir.
Are these values that I have written, are they visible to you people on laptop?
Yes, sir, it's visible.
Fine.
Yes, sir.
Fine. Yeah. Simplification part, as usual, take sigma to the left hand side, squaring both sides, 1 also to left hand side, then squaring both sides. So you will have one of the term, one getting cancelled. So 1B and 1B goes off, you are left with B given by 79.65 or 80 mm, rounded up to next value. Finished? Can we go to the next problem? If anyone needs time, let me know. Otherwise, we'll go to the next problem. Yeah, not on this problem.
Sir,
Yeah?
sir, 1 minute previous problem we want to note down, sir. I want
Yeah,
to.
okay.
Sir, done, sir.
Yeah, not on this problem. A machine member can be considered as a simply supported beam of 1 meter length. Cross section of the beam is 60 mm by 60 mm square. Determine the instantaneous maximum deflection and bending stress if a mass of 15 kg falls from a height of 250 mm at the midpoint of the beam made of steel. Okay? Please note on this problem. A machine member can be considered as a simply supported beam of 1 meter length. Please note on the problem. Okay, done? Note it down. Finished up? Okay. Please look here now. Please look here now. A machine member, I'll go through the problem. A machine member can be considered as a simply supported beam. This is how a simply supported beam is represented. Whenever a beam or a shaft is mounted between two bearings, then it is considered as a simply supported beam. Okay, are you there? So whenever a shaft is mounted between the bearings, then it is considered as a simply supported beam, first thing. And it has got a length of 1 meter. Okay, so the length of the beam that is considered here is 1 meter in length, that is 1000 mm. That is the length of the beam. Cross section is a square, so it is square of 60 by 60. Okay, 60 by 60. This is 60 over here, and this is 60 out there. Okay, and the determine instantaneous maximum deflection and bending stress if a mass of 15 kg. So here he has given you mass of 15 kg. But what we have there is W. Okay. So what we have is W. W is equal to what? W is equal to m into acceleration due to gravity, that is m into g. So this 15 kg should be multiplied by 9.81 for that to get converted into Newton. Keep that in mind. Okay. And fall from a height of 250 mm. So height of fall is 250 mm at the midpoint. Okay, of the beam made of steel. So we need to find out bending stress, and also we need to find out maximum instantaneous deflection. Please go to table 1.4 and look for simply supported beam with central point load. Please go there. So, and let me know the equation. Anyway, I have typed there. L is equal to 1000 mm given in the problem. Okay. And cross section B is equal to, it's a square cross section. B is equal to H is equal to 60 mm given in the problem. Then W is equal to 15 kg into 9.81 Newton, and then what we are given with is height of fall is equal to 250 mm. Okay. Again, it's a beam with a transverse load of 15 kg. So therefore, it is subjected to bending stress. For a simply supported beam with central point load, the equation for static deflection is given by WL cube by 48 EI. So I is BH cube by 12. Since he has told you steel, so take or assume E is equal to 207 GPa or 207 into 10 power 3 megapascal. Okay, are you there? So this is megapascal over here, right? So find out sigma. Bending moment is what? So please look for simply supported beam with central point load. M is given by FL by 4. Okay. Yesterday, if you remember, Tarun Pachauri read this from the table 1.4. For a simply supported beam, M is equal to WL by 4. Substitute over there. Z is BH square by 6. We know B and H both are given over here, right? So stress is known, delta is known. Okay, then find out the stress induced in the member because of 15 kg load that is falling from a height of 250 mm on the simply supported beam, and maximum instantaneous deflection is given by root of 1 plus 2h by delta into delta. Give me the values. Please look for M is equal to WL by 4. From table 1.4, check there in table 1.4, column number 2, you will get moment to equation. And the last column, you are going to get maximum deflection is equal to FL cube by 48A is what he has given you in the data handbook. Okay. Now, give me the value of sigma I. Give me the value of sigma I and maximum instantaneous deflection. What is the value of delta? First case, delta is equal to What is the value of delta? Yeah, give me the value of delta. Someone.
0.0137.
0.0137. That's correct. Okay, good. 0.0137. That's the value of delta. And then calculate the stress, static stress. Sigma is equal to m by z. M is WL by 4. Z for square rectangular cross section is given by BH square by 6. B and H are same. Simplify. Give me the value of sigma.
1.021.
Yeah, that's correct. Excellent. Okay. It is 1.021. So from there, give me the value of sigma I.
$195.88.
Yeah, that's excellent. 190. 196.7 is what I got. Anyway, doesn't matter. Somewhere around 196 megapascal is the value of impact stress. Okay. Look at the difference. Gradually applied load will have only 1 megapascal stress, whereas when it is dropped from a height, its stress is going to be 196 megapascal. Okay. So that is the amount of difference that you are going to get when you are considering impact. So therefore, impact is very, very, I mean, it's more prone for high stress being induced. Okay. So whenever we design any component, we should keep that if it is subjected to impact, what is the stress it's going to be. So that's why all this crash test and all, I think they use these values of impact only. What is the maximum instantaneous deflection?
.62 millimeter.
Pardon me?
2.62 millimeter.
Yeah, correct. That's correct. 2.62 millimeter. Okay. Look at the static deflection 0.013 compared to 2.62 millimeter, which is a big number. Okay. So that's the effect of impact. Okay. So whenever we design the components, we have to see whether the component that you are designing is subjected to impact. If it is so, you need to design in a different way with different cross sections. Okay. Others, could you do? Please note down if you are not able to get the answer. Please note down from the screen. Please note down from the screen. If you are finished, then we'll go to the next problem then. Darshan, Kiran, are you able to understand?
Yes, sir.
Yes, sir.
Fine, fine. Please note down. If you are finished, if we'll go to the next problem. Okay. Please write the equations. Please write the substitution. If you do not write substitution and all in the test, you are not going to get marks, whether it's test or main examination. If you don't substitute the values, you will not get the marks. Okay. It will be presumed that you have copied the final answer from someone else. Okay. Okay, we'll go to the next problem. Anybody needing time? Yeah, I think we'll go to the next problem. Yeah, on similar lines probably. Just note down this problem. A machine element in the form of a rod of rectangular cross section is supported on 2 points 1000 mm apart. The width of rectangular cross section is B. Depth of the cross section is 80 mm. This beam is to be designed to sustain a central transverse load of 1 kilonewton falling from a height of 30 mm. Determine the width. Okay. On similar lines, with reference to previous problem. Okay, so find out the width of the beam. So here what you need to do is you have to assume or select a suitable material. Okay, you need to assume a suitable material and then solve a factor of safety also and then solve the problem. Okay, so here what you have to do, because you are not given with the so here you can take selecting C40 steel and FOS equal to 2.5. So that's going to be 324 divided by 2.5, that is equal to 129.6 megapascal, that is equal to sigma I. Okay, this is the addition for this problem. Please take down. So because on the width you have to find out. On the left hand side you will have another unknown. So you need to choose the steel and factor of safety and solve the problem and get the value of B. Solve the problem and give me the value of B. Meantime, answer a roll call. 1,
Present, sir.
2, Abhishek GL, 3, 4,
Present, sir.
5, Ajay Sunil. 6.
Present, sir.
7. 8.
Present, sir.
9. Nambia. 10.
Present, sir.
11. Biban. 12.
Present, sir.
13. 14.
Present, sir.
15.
Present, sir.
17.
Present, sir.
Hey, Bhat Kausar, I think you are class representative, no?
Yes, sir.
What happened to this Akshay Jadhav? What is his problem?
Sir, I'll ask him and let you know, sir.
Yeah, please do that, yeah, okay? Because
Okay,
he's
sir.
not there for last 12 classes.
Okay, sir.
Just find out and let me know.
Okay, sir.
Yeah. 18. Govindraj. 19.
Yes, sir.
20.
Yes, sir.
21. 22.
Present, sir.
23.
Yes, sir.
24. Chaitanya Vamshi. Ritiksha is also there. Okay. Chaitanya Vamshi. Karamjit Singh. 26. 27.
Present, sir.
So 26 present, sir.
Awasthi.
Yes, sir.
30.
Sir, 27.
Done. 30. 31. 32. 33. 34.
Yes, sir.
35. 36.
Sir, yes, sir.
Who? 36,
Yes, sir. 36.
36. 38.
Kumar.
38. 39.
Yes, sir.
40.
Yes, sir.
What? Nimala Vagmesh? Are you there? 36. Yes, 36. Nimala Vagmesh. Forty-one.
Yes, sir.
42. Pinto?
Yes, sir. Yes, sir.
Yeah, 43.
Yes, sir.
44.
Present, sir.
45. 46. 47.
Yes, sir.
48.
Yes, sir.
49.
Yes, sir.
50.
Yes, sir.
51. 52.
Yes, sir.
53.
Yes, sir.
54.
Yes, sir.
Shravan Saluja, what is the answer?
Sir, solving 5 minutes. 2 minutes.
Yeah. One, 55. 56. Siddharth. 57. 58. 59. 60.
Yes, sir.
61. 62.
Yes, sir.
63. Vivek. 65. 66.
Present, sir.
67. Saksham Singh.
Yes, sir. Present, sir.
Hey, what is sleeping, huh? Huh? Saksham Singh.
Yes, sir.
Chaitanya Patel,
Yes, sir.
Mahesh Maniwal, Nishant, Ramesh, Shashank, Akshat,
Present, sir.
Sautrik Roy,
Present, sir.
Mahima,
Present, sir.
Srivatsan.
Present, sir. Present, sir.
Yeah. Suman Xavier, Madan Kumar, Manu,
Yes, sir.
Shadab Khan, Ganesh R, Vijay Kumar,
Yes, sir.
Rishi S,
Yes, sir.
Zahir Hussain, Zahir. Yeah. What is the value of Shravan Saluja? I think I asked you the value of V.
86.6
80.
6.6
86 you are getting. What is the value of sigma? What is the value of sigma you are getting?
Sir, sigma I am getting 1 second.
What? Your friend.
Sigma is
Tell me.
1 second. Yes, sir. 1 second. Sigma by is 324 divided by 2.1.
325.
129.6.
That is 1.129. I say. Bending stress. That is sigma I. Bending
Sigma
stress.
I, yes.
Bending stress. WL cube by, M by Z you get, no? What is that
Yes, sir.
value you have got?
M by Z. 1 second.
Yeah. What you have not done, huh? Simply someone said the answer, you are telling. Correct, Correct, Shravan?
Yes, sir. I didn't complete it.
That is what. Don't cheat. Don't try to cheat, man. Involve or
Sorry.
do something. Doesn't matter even if you make mistake, right? Yeah.
Okay.
Please note down. This is right. Sigma you are going to get is 234.4 by B. M by Z. Okay. M by Z. WL by 4 is bending moment. And BD square by 6 is the section modulus. Solving that, you will get sigma to be equal to 234.4 by B. Okay. Delta will be WL cube by 48 EI. That will give you 2.36 by B. Okay. And assuming C40 steel and FOS of 2.5, sigma I will be 129.6. Right. Simplifying that, you will get somewhere around 89. What, Tarun? You got 86, huh? Charishma?
87.
86.75.
87, sir.
Oh, 87 you are getting?
Yes, sir.
Yes, sir.
86.76.
Yeah, doesn't matter. I am getting around 89, maybe. Decimals in between might be
Yes,
a variation. Okay. So
yes.
don't worry.
Decimals is the valuation, sir.
Yeah. So that's what you get. Around 88 mm. It's fine even if you're
88.14, sir.
Yeah?
88.14.
Yeah, that's what. 88.3, somewhere around 88, 87. It will vary depending upon the fractions that you take, decimal points that you take. Okay. Doesn't matter. Even if it is 87 mm also, 88, 89, 87. So they are fine. Anybody needing time to note it down? Or shall we move to the next problem? We go to the next problem then.
Yes, sir.
We'll take up. Note down this problem. 11. Yeah. This is another set of type of problems. Please note down the problem. Determine the diameter D of a round rod 200 mm long, fixed at the bottom end and free at the other end to sustain a weight of 5 kilonewton falling onto the rod axially from a height of 40 mm. Please note down the problem.
Here we'll take the material as steel only, sir.
Yeah, naturally. Yeah, I'll go for the benefit of others. Please look into the problem. Determine the diameter D of a round rod, 200 mm long, fixed at the bottom end. Okay. So how the rod should be? How the rod should be? It is something like this, which is fixed at the bottom. Correct? Huh? This is what we have got, right? We need to find out diameter D of the round rod. That means this fellow is having cross section of circle, right? It's a circular cross section member. Okay. And it is free at the other end to sustain a weight of 5 kilonewton falling onto the rod axially. So the load of 5 kilonewton is falling onto this rod axially from a height of how much? It is 40 mm. We need to find out diameter D of the round rod on which, it's a question mark, okay, on which a 5 kilonewton load is dropped axially from a height of 40 mm, okay, and length of the rod is 200 mm. This is the length of the rod given in the problem. It is 200 mm, okay. This is the given. Yeah, whenever you are given with to find out dimension without giving the material, then we need to assume a suitable material. Again, here we are going to take C40 steel and a factor of safety of 2.5. Okay, so our sigma I is fixed. Fos is equal to 2.5. Okay, so 324 divided by 2.5 will give us sigma I to be equal to 324 divided by 2.5. So that will give us 129.6 megapascal, correct? So it is 129.6 megapascal. So this is sigma I that is done with. Now it is an axially loaded, okay. Axially, the load is being dropped axially onto this rod, right, from a height of 40 mm. All right. So what is the type of stress that is induced here? And what is the type of deflection that you are going to have? It's an axially loaded member. So the deflection is going to be, what is the equation for deflection now? For an axially loaded member, delta is given by what? PL by AE. Right? PL by AE is the equation that you need to use for finding out delta. And stress is given by what for an axially loaded member? Stress is given by P by area of cross section. Okay, so P is known, length of the bar is known, area we don't know, pi d square by 4, and Young's modulus you can take it as 207 into 10 power 3 megapascal. So you are going to get delta in terms of D in the denominator, right? Similarly, here P is known, area of cross section is not known, I mean, D is not known. So therefore, sigma you get in terms of D again. Then go to sigma I equation. Go to sigma I equation. Sigma I is known 129.6. Then substitute the value of sigma in terms of D. Then delta in terms of D. H is given to be equal to 40 mm. Okay. H is 40 mm given in the problem. Give me the value of diameter D. Anybody not able to understand this? Anybody who could not understand? Please work out, all of you. Please keep everything in terms of A. Instead of D here, you can also do one thing. Instead of D here, you can keep it as A. Okay, and A here also. Instead of D, you keep it in terms of A only. Then
So if we keep it as D, it will be D square, no sir, for delta.
That's what. Instead, you take it as A here and A here. Then finally, you will get a value of A that you equate it to pi d square by 4.
Okay, sir.
Then it will be easy to solve. Okay. D is equal to, give me the value. Others, please work out. All of you, please involve and work out. Okay. It's an axially loaded member. So therefore, delta is equal to PL by AE. If it is a transverse loaded member, then we go to table 1.4. Depending upon the condition, we used WL cube by 3EI. Then for a simply supported beam with central point load, we used WL cube by 48 EI. Here, in this case, it's an axially loaded member. So therefore, deformation or deflection is given by PL by AE. This is what we have learned in our basics of mechanics of materials. And for an axially loaded member, stress is equal to load by area of cross section. Whereas in beams, it used to be M by Z because it is subjected to transverse load and bending stress. Are you getting the clarity? If anybody has got any doubt in these things, please let me know. These are all very, very basics. Next fatigue topic, we will be doing in each problem, we will be doing these things multiple times. So have clarity at this stage itself. Yeah, delta value. It does not take so much time. Sigma is equal to P is what? 5 kilonewton. That is 5000 here. That's it. Okay. 5000 by A. Delta is PL by AE. So P is known, L is known. So what you get delta is 4.83 by A. Correct?
Yes, sir.
Okay. So
Sir, is the value of D 177.4?
yeah, exactly correct. It is 178 mm.
178, okay.
Yeah, nice. Good. Yeah, it is 177.8 is what I have got. So rounded off to 178 mm. Anybody who could not get this value?
Got 176.9.
Yeah, that's fine. That's fine. That's fine. That's
I
fine.
got 180.
180.
Yes, sir.
Just take maybe area you would have taken more decimals. I have stopped at first decimal itself. So for that,
Yes,
I
I
have
took 3 decimals.
Yeah.
I took 3 decimals.
Yeah, I've taken 24853.4 millimeter square. That's all. Maybe you would have taken little more number of decimals. So there can be variation over there, right?
Yes.
So ideally, how many decimals should we consider? So like in MOM, we used to consider 4 decimal places.
4 decimal places are.
Yes, sir. In MOM, we used to consider 4.
Oh, okay. Now, that much for classroom design, I think that much may not be a requirement. But nevertheless, what will happen? No, sometimes it's like this. Instead of 176, you would have got 180, something like that. So maybe up to 2 decimals will be more ideal.
Okay, sir.
Again, that depends upon the type of application, right? So, but nevertheless, people. Are you done with? Are you done with the problem there? There was some temporary disconnection.
Yes.
Okay.
Yes, sir.
Okay, then we'll continue on Monday.